As I mentioned during the presentation, we can import the AutoCAD DXF file. So I will start with importing the DXF file. Select the layer you want to import. So this element has been imported. As I mentioned, we provide the worktree here. So now I will specify the material and section properties first. Firstly, for the material, we provide the various database. Among those, I will use the Eurocode. And for the section property, also it's same. We provide the various database for the American and BS, DIN, Uni, so on. So select your desired sections. So we can continuously add the desired section properties here. So it's very easy to generate the properties. So it's done now. And then let's try to create the columns. For this, I will extrude the nodes. Select all the nodes and then extrude from node to line element. Specify desired material and sections. Then enter the dimension. Apply. So column is now generated here. If we want to change the properties, it's very easy as well. Just selecting certain elements and using the drag and drop, the property has been easily changed. So using this worktree, we can see which property has been assigned to which element. After that, now I will try to create some brace. Also select desired section property and simply clicking two nodes, we can generate the brace very quickly. It's the same. Okay, so it's done now. And since this is the bracing system, so I will assign the beam and release for all girders. Select girders. The red mark means the girder is selected now. And then go to boundary conditions and assign pinned, apply. So we can see it has been assigned now. And then create load. In order to create the load, firstly we need to create the load case. For this, I will create the dead load. Superimpose the dead load and live load. Those type will be used during the auto generation of load combination. If you are not going to use the automatic generation of the load combination, then it will not affect any analysis results. And also generate the wind load. It's done now. And for the self-weight, it's very easy. just go to self-weight and entering the -1. Self-weight can be automatically assigned. We can see the data, which data has been entered now. After that, I will enter the floor load. As I mentioned, there is two ways to consider the slabs. Firstly, modeling the plate element. The other way is considering the floor diaphragm. I will use the floor diaphragm, and self-weight of the slab will be considered using the floor load. So for this, I will enter the floor load. Firstly, define floor load type. So enter the floor load. Then now we can assign it. Assign the floor loads to the specified area. So now we can see the floor load is now entered here. I selected two-way. We can select one-way, two-way, and any other types. Then I'm going to now generate the building. Go to Model, Buildings, and Building Generation. In order to make the 5-story building, I will copy 4 times with the 4-meter height. Select all of them and apply. So now the 5-story building has been very easily generated here. Then we can now define the support. For this building, I will enter the support only. I will resist only the translation. Click apply. We can see the support has been assigned. And we can also define mass. In the structure type, we can check on this option, convert self-weight into mass. Then this self-weight will be considered automatically. And as we assigned the self-weight of the slabs using the superimposed dead load, so we can also enter those using the load to mass function. So select the superimposed dead load and click Add. So mass data has been now entered. And now we will enter the story data. Go to building again and story. As I mentioned, program can automatically recognize the Z-axis nodes. And then this data can be entered. As we can see, floor diaphragm can be considered here. If we do not want to consider it, just simply click this. Then it will not be considered. Now I will try to enter the wind load. For the wind load, we provide the database for the static wind load. We can select the database for the IBC, UBC, and MBC, Eurocodes, BS, so on. So select desired load type for the X direction first. By clicking this button, we can see the amount of the load for the elevation, pressure, and wind force, story force, story shear, overturning moment. Apply, and also Y direction. Okay. So wind load is also now entered. So as you can see, all the entered data can be checked in this worktree. For the seismic data, we can use the static seismic load as the usage is very similar to the wind load that I just done. Or the other way is considering the response spectrum load. So go to load, response spectrum data, go to response spectrum function. midas also provides a database for the spectrums, IBC, UBC, so on. So select the spectrum type, ground type, and some other parameter like peak ground acceleration, importance factors, so on. Then function can be automatically assigned. If you have your own data, then you can select user type, then you can simply copy and paste from the MS Excel or any others. Click OK. And then specify the response spectrum load case. If we want to consider the accidental eccentricity, just click this option and specify the percentage. Or you can specify your own selves. We need to perform the eigenvalue analysis. Click Add. And also Y direction, which will be 90 degree. Okay, it's done. So all the required data has been entered now. So let's perform the analysis. As I mentioned, the analysis speed is very fast. So analysis is now done, and let's check the results. Reaction, deformation, force, stress can be checked. Firstly, let's see the reactions. We can check with the values. All the results can be checked in the table format as well, which is the comparable with Microsoft Excel. We can simply export the data to Excel. And deformation, let's see the deformed shape. So this deformed shape, we can check it. Or wind load. Also member forces for beams, beam diagram. So we can check this beam diagram. Also it's same. We can check it with the tables. And in order to perform design, we need to generate the load combinations. Go to stress and steel and select desired code, Euro code and American, CSA, BS, so on. Then load combination can be automatically generated. As I mentioned, the load case that we specified here will be used to generate this auto generation of load combinations. After that, another thing, we can also check the vibration mode shape. First mode, second mode, or we can check the multiple mode. As you can see, and this, if we go to the tables, we can see the frequency and period, also modal participation, masses for its different modes, and also modal participation factor, so on, eigenvectors as well. Now let's try to perform the design. We can perform steel design or concrete design or SRC, which is composite design, based on the various design code. For example, for RC, it's same. We provide the Euro code or ACI latest one, and CSA, VS, so on. So select the desired load case, design standard, and now we can try to perform design. After design, the table will be displayed, and so we can check the design results in the table or graphical report or detailed report. For example, the red color represents the section is not proper. We can see more details in the graphical report. It gives the design information, member force, which is used for the design with the critical load combination number, and design parameter, which is for the embrace length, effective length factor, equivalent uniform momentum factor, and checking results for the axial, bending, combined, and shear force. As you can see, the bending resistance is not satisfying the cost requirement. Also, using the text format report, we can see more details. More details about the design factor, like the section properties and the design forces, and the section classification, if the section is compact or not, plastic or not. And then axial resistance, shear resistance, bending moment resistance about major and minor axes, and lateral torsional buckling resistance, and combined resistance, also deflection check as well. So each detailed results can be checked in this text format report. So that is the main procedure using midas gen, from the modeling to the design. And then let's see midas gen now. So midas set. As I mentioned, Gen is based on the FEM analysis software, which can be applied for any shape of the structure, any type. And Gen has design features as you have checked just before, but there is some limitation of the designing. Like for the joint design, we do not provide it in midas Gen, or some other designs like Cobel or some special footing designs like combined footing or combined walls. We cannot design them in midas Gen. However, by using it with midas Gen, we can satisfy all the requirements of the design. So midas Gen is collection of practical design tool for the structural engineers performing everyday structural unit design. So midas set is designed to be simple, fast, and accurate. It enables engineers to systematically and consistently manage design reports as per the design standards like ACI, AISC, BS, and Taiwanese, so on. So for each member design, we will check it with the program, and then also we will check the design report. Before go to in details for each member, I would like to briefly explain why midas set is good. Firstly, midas set is very easy to carry out the structural design, which meets the engineering practice. So with very simple input, we can check the design results once we enter the data. And if the data is not satisfying the design code, it will give a warning in the red mark. So it's very intuitive and simple. Even though it's very fast and simple tool, but it gives the accurate calculation results, which meet the design standards of the ACI, BS, AISC. And after designing them, we provide the high quality outputs. We can save those results to graphical format, and also if there is any improper design results, as I mentioned, it's very easy for the recognition by displaying them with the red mark. This shows the which design we can do, which unit design midas set provides. We provide the footing and retaining wall design, RC, composite member, and steel member. For the footings and retaining wall, we can design spread footing and combined basement wall design, and basement buttress cantilever retaining walls. For the RC member, we can do slab, beam, column wall, cobble, bracket, and combined wall design. For the composite member, we can do the beam and column design, and also base plate design. Lastly, for the steel member, we can do the beam column design and plate girder design, crane girder, web opening, and base plate design. Let's see with the RC column design first. RC column design module provides the design for the rectangular and circular reinforced concrete columns, which subjected to the axial force and biaxial moment and shear force. This provides the 3D PM interactions to check the resistance of the section. We can select the option if we want to apply the block stress distribution or parabolic stress distribution. And in order to check the ratio, it provides the ratio between the capability of the section and the member force of the section. When you check this ratio, we can determine if the ratio will be based on these two, which is the eccentricity ratio, the rate of the moment with the axial force, or only with the axial force we can check the ratio between two. So we can determine between those two. Let's check with the program first. So let me open my dataset. This is the main frame of my dataset. So we can see which design is available for the IC, steel, rehabilitation, and some useful tool. So let's start with RC beam, RC column. So this is the frame, which looks very simple and easy. So we can do the design for the rectangular shape or circular shape. For entering the member force, we can enter the value here, or if we want to specify various values, we can enter them with this table. And then enter the desired section size. Also for determining the slenderness ratio of the member, we can specify those factors. And rebar requirement. We can specify the design code among those. And rebar splicement option is provided if we want to consider the spliced length when we determine the spacing between the rebars. And this is the stress distribution between the block and parabolic. And find the equilibrium condition between the only axial force or eccentricity ratio that we checked in the graph. Okay. And some other tools are available. So when our desired section size do not meet the code specification, when you're performing the design, when you're performing auto design, the program will try to change the section size. So with which rule we will change the section size can be determined here. So minimum dimension of the section, maximum dimension, and increment. So by clicking this button, the design report is shown here. It's the sections and geometry and materials, magnified moment, and member force and moment. Then we can see the axial and moment capacity with the PM interaction curve and the shear force capacity. There is two different options, performing auto design and force check. When performing auto design, if our desired section size do not meet the code, performing auto design, our desired section was 30 centimeter to 30 centimeter. But since it do not satisfying the code, the program automatically changes the section size to 50. So this is the design. The program recommends the required section size. If we perform the checking, then program will not change the section size, and it will just check if our desired amount is satisfying or not. So if not satisfied, as you can see, the red mark will be shown here with the NG. So that is column design. And RC beam design. Usage is also similar. We can design the rectangular or T-shaped beam subject to bending moment, shear force, and torsion moment. So we can select the rectangular or T-shaped section and enter the member force is the same. Beam dimension and material property. Then by clicking auto design, program will give us the design results here. For the top layer, bottom layer, and the torsions, scan rebar, so on. For the torsion moment capacity and bending moment capacity. All those reports can be saved with the PMF or EMF format. For example, if we save it with the EMF file, then the report can be checked, as you can see here. Then go back to the presentation. We just checked the regular shape design. If we need to design the irregular shape section, also we can do it with midas set. So with the column irregular, in order to generate the irregular shape section, we can use the section input tool. So we can draw the section. For example, this shape of section. Also we can enter the lever. Enter the spacing of the lever. So it's done now. And then go back to the midas set main page. We can change the lever location or the lever dimension. Okay. And the shapes outline. By clicking force check, the program will do the design. So with our required levers, it will check the magnified moment and member force of the moment. The warning message is shown here. Lever rate exceeds the maximum. So when it do not satisfying the code, then this warning is showing. When you enter the certain data, it will give us the bubble text here. So it becomes easy to specify certain data. For the RC wall design, we can design subject to the axial force and moment and shear force. In midas, we can design RC walls for the straight wall only. Using the midas set, we can design the combined walls as well. For example, wall combined. We can specify the member force here, and then wall dimension and levers. By clicking Auto Design, the result of the wall design is shown here. Similarly, we can do the footing design. When we do the footing design, you can check the diagram of the shear force and bending moment. And basement wall design. When the basement wall subject to the soil and groundwater pressure, as we can see in this picture, we can check the member force of the basement wall. So those diagram is shown. We can specify the various data with the soil pressure for each different layers. And spread footing design. Only this spread footing design is also available in midas. and basement buttress design. So using this basement buttress design, program will check the lateral pressure, shear force, moment, so on. And the cantilever retaining wall design, like this type of the walls, we can design them as well. So mainly we check the overturning, sliding, and soil bearing pressure. And the composite beam design. For the composite member, also similarly we can do the design. Composite base plate as well. So if we check with the program, for the composite member, this is the composite beam module. So we can check those composite beam design for effective width. Program will calculate and then calculate the section property and member stress, horizontal shear check and shear connection design, deflection check, and heel drop vibration as well for this slab. And continuously, for the steel member, we can do the steel beam and column design. H-shape box pipe, T-shape, and channel section is available. So let's see the steel beam and column design. So those show the applicable section shape. We can select from the database, or user can specify the section size by clicking the auto design. Program will perform the design. For these steel columns, we can specify the effective buckling length factor. Since midas set is unit member design, those factor can be specified by the user. Also, the moment magnification factor can be specified here. So by entering the certain value and selecting it, the CB factor can be automatically considered. So design results can be checked here for this steel member. The factor which has this blue line has more explanation for better understanding. So from the bending stress checking to the stress of the shear, we can check details. For the steel member, we provide the AISC and AISC LRFD and also BS code are provided. The member list, we can also check it or modify the properties here. So still it's also same. We can check it with auto design, which the program can find the optimized section size, or we can do the first check only. Also web opening beam design. When the steel coder needs to install the opening because of the mechanical equipment, then we can check the capacity of the section. And the composite plate design. And the crane beam design. So for the large retail store or plant structures, crane beam is required. So by specifying it, the program can design those crane beam. It will check the local buckling and stress and stiffener stress and fatigue in the crane beam. As I checked during the design, then once we click the button, those reports can be provided. So this report can be saved with the graphical format. Okay, so that's it for the Midas Gen and set introduction. If you have any question, please let us know via questions window, then I will answer for your questions. Firstly, for the question, how we can consider the hollow core slab at Midas Gen. In Midas Gen, as I mentioned, the slab can be considered with the plate element or floor diaphragm. When we use the floor diaphragm, we assume that slab is very rigid. But when this slab has the holes, the slab stiffness would not be very rigid. So in this case, we recommend to use the plate element. So using the plate elements, we can consider any shape of the hollow. For example, we can create the element, we can create the plate element. For example, I will try to enter the plate for the slab here. For this, I can create the meshes. So select the line element here, and then by specifying the mesh size, the mesh elements can be generated. As you can see, if you have any hollows, you can firstly generate the hollows, and then the program can consider that hollow so not to generate those meshes to certain area. Or we can select certain elements to make the hollows based on the real requirements. For example, let's say this is our core and we need to make the holes in here. Then just making like this. Then we can generate the program, we can generate those hollows in the slab. And between midas set and gen, since midas set is just entering the data, I mean the member force, so there is no interaction between gen and set. Just we need to enter those values from midas gen global analysis. So there is no direct interaction between gen and set. We need to manually enter those data to midas set based on the global analysis results in gen. In midas set, the unit in the output is following the code. For example, if you select the metric code HIM-02, then the results will be shown based on those SI unit. So the output code is based on the which code you selected, if your code is metric or not. And this unit is based on the unit setting. So if we change it as the US unit, then it will be changed to like the inches, feet, or pounds, so on. The Revit interface. Is it possible to import the drawing file from Revit? We have the data transfer function with Revit structure. So if you generate the models with the Revit structures, one of the Revit tool, then we can directly import the walls and beams, columns to midas gen. So if you were working on the Revit structure, then it's possible. In midas gen, we have the function to design for regular shape. So only the straight wall can be designed in gen. And recently, gen has been implemented new feature which calls General Section Designer. Using this option, we can check the capability of the section for beams or columns or walls. So the irregular shape design is a little bit different. Using this GSD, for example, any shape, then by doing the finite element analysis, we can check the capability of the section. Similarly, we define the member force here, like we have done in midas set. So for the specified member force, program can check the capability, like the ratio of the certain section. So there is no direct design feature for the irregular shape wall, but using GST we can do the similar. So for the hollow core slab in midas gen, as I mentioned at the beginning, we can generate the slab element, plate element, as you can see here. Then we can consider those. So we need to generate the plate element for the slab, and we can make any shape for the meshes. So we can make any shape of the hollow for the cores. So using the plate element, we can do it. For the stairs, normally for building, we do not consider the stairs, but if you want to consider it, using the plate element, also we can do it. So for normally, if you need to consider the stairs, you can make the stair with just a simple slope and then generate the plate element. Then we can consider the stairs as the simple slope, not the real shape of the stairs. The unit system, let me clarify once again. So if you want to work on the metric system, then go to Tools and Unit System Change. Then SI unit. Click OK. Then you can see megapascal and millimeter is specified here. For the results, if we want to check it with the metric system, go to Environment and select Metric System Code here. OK. Then both are the metric system. If you want to work with the inches or pound, which is the US unit, then similarly, go to Unit System Change it to US unit for the input. For the output, go to Environment Setting and select the other code, which is based on the US unit. OK. Then both are now US unit, pounds and inches, feet. So midas set to design the RC beam with the large opening. No, we have the beams with the opening only for the steel. So we do not have the function for the designing RC beam with the large opening in midas set. So steel connection design is not provided in midas gen. And post-tensioning slab is available. In midas gen, we can do the post-tensioning for beam. For the slab, so we can directly assign the post-tensioning to the beams only. If we want to do the post-tensioning in the slab, we can make one dummy beam which is connected to the slab and then assign the post-tension to that dummy beam. Using this alternative way, we can consider the post-tension slab. So there is no direct way, only we can do it with the alternative way. And the question for the importing data from ETABS to GEN. As I mentioned, we provide only the SEP 2000 import, which is the S2K. Since ETABS can generate the S2K file, you can import them to midas gen. However, as you can see, the version you need to be careful. Currently, we are providing the version up to 8. So for the Levy structures, we can import the 3D model absolutely uh, available. We can do the 3D model import. Precast slab. So post tension, as I mentioned, the slab post tensioning or pre-tensioning can be done with only the alternative way. The mat foundation's generation is the same. We can generate the mat foundation with the plate element. And in order to consider the soil stiffness, we have various springs. Using the point spring support, we can do tension only, compression only, or multilinear. And also for the plate element, we can specify the surface spring support with the nodal spring type or distributed spring type. Using those various springs, we can consider the mat foundation with the plate element. Currently, in midas Gen, we provide up to ACI 2005 and INSET 2002. As I mentioned, we are continuously updating the design code, so those codes, the latest code can be implemented in the sooner future. Output design report for midas Gen. As I mentioned during the presentation, midas Gen provides the design report for the graphical format and the detailed text format. So for example, if we designed this column, for this column, we can see firstly this graphical report, which summarizes the design result. And for the detailed results, we can see this text format report. So we can see all required data and code-related equations are listed in this report. That's Gen design. So we can design concrete beam, column, brace, and wall. For the steel, also same. Beam, column, and brace, not the walls. And for the composite, beam and column design is available. Also, based on the Eurocode, we provide the slab design, slab and wall design based on the Eurocode too, as well as mat foundation design. Still, connection design is not provided in midas Gen. So as I mentioned before, midas Gen can do the post-tension slab with the alternative way only. No design is available for the post-tensioned member. The benefit comparing to other FEM software of midas Gen is firstly, the usability is very simple and easy. Also, analysis speed is remarkably fast. And we provide the all-in-one design feature as we have checked. For the simple building design, it does not take a long time. It will increase your productivity a lot, as well as with the dynamic report generation that I mentioned. So from the simple modeling to the making design through analysis and design, it's very fast, and also we provide the accurate results. And the important thing is our midas headquarters directly support you to resolve any difficulties during you applying your project. So we are always taking care of your emails, questions, and also we continuously provide the training. So wind load we checked during the demonstration. So we can enter the wind load with the static wind load. Static wind load considering this floor diaphragm. As mentioned at the beginning, we provide the Tekla structure interface. With the latest version Tekla structure, we provide the interface between Gen and Tekla. Round trip is available. Also, we have many project applications, so we can do any shape of the structures like water tank as well, using the hydrostatic lateral load. We can consider those water tank and domes as well. One thing, midas Gen can consider only the straight elements, no curved elements or no curved plate. But there is just, by dividing it into various elements, we can consider those domes or other shapes. I can show you one of our project application which models domes. For the masonry structural analysis, one of our users have applied midas gen for modeling the old church. For example, this type of dome we can do with midas gen. So by creating the meshes with some other useful tool, midas fx plus for generating the mesh, and then we can design doing those whole analysis for the plastic analysis. So any shape of the structure can be modeled in Gen. And so shear wall design is available in midas Gen, as I mentioned here. So if we have the shear walls, we can design it in midas Gen as well as midas set. And for the slabs, as I mentioned, we provide the slab design as per the Eurocode 2 at the moment. When we're designing the slabs as per the Eurocode, we can do the flexure design and shear design, which is checking the punching shear in the slab. So at the moment, we provide the punching shear check as per the Eurocode. And behavior factor for the spectrum. Behavior factor will be calculated based on those input data. And actually, behavior factor is applied during the design, not the analysis. So in the Eurocode, behavior factor is Eurocode design concept. The seismic design, the capacity design as per the Eurocode 8, we need to apply the behavior factor. So this behavior factor can be directly entered by the user, or program can automatically calculate it based on the entered value of this one. Or also this structure type will affect about this entered value. So behavior factor can be entered by the user or automatically calculated by the program. And the element stiffness, how can we reduce the stiffness? As mentioned during the presentation, midas gen provides the section stiffness scale factor for the beam columns. So by selecting certain member, then if we want to consider the reduce the stiffness, then by entering the factors. For example, I want to consider only 80% of the major axis stiffness, then just click Add. Then this reduced stiffness will be applied for the analysis and design. Another question, if the model has to be designed, do we have any edit format to modify some properties? I'm not sure if I understood correctly. If we want to change the element property for certain members, for example, If we want to change only this element section property, then firstly you need to specify the certain element type. For example, I will try to just enter the solid rectangular shape. Then by selecting it, and simply drag and drop, the section can be automatically modified. So it's very simple to edit, change for the entered data. For the masonry structure, we provide only analysis as it performs the plastic analysis. For design, we provide the only RC wall design, not the masonry wall design. If we want to check the capability of the masonry wall, then you can perform the pushover analysis for the masonry. So for the masonry type, we provide the plastic analysis or pushover analysis. And wall design, we provide only the RC wall design. Story drift can be checked in the various tables. If you want to check the story drift by checking the certain load case with the allowable ratio, we can check the drift of the story. And the summary of the wind or seismic load. As I mentioned, by clicking this wind load profile, then we can see details with this detailed report. If we want to check it with file, make a wind load calculation sheet, then the detailed can be checked with this text report. And the slab stiffness can be reduced. Yes. In order to consider the reduction of the slab, we can enter it with the thickness. Normally, the reason we need to reduce the slab thickness is because of the cracks about the out of bending force. So, in the thickness, we can differently enter the thickness for the in-plane and out-of-plane. For example, if we have a certain amount of the cracks, then the stiffness of the out-of-plane needs to be reduced, whereas the in-plane stiffness needs to be remain as its own thickness, regardless the cracks occurrence. So, specifying the in-plane and out-of-plane thickness differently, we can reduce the stiffness of the slab. And how to design the waffle slab? Waffle slab cannot be designed in Gen. We can design only the flat slabs. So let me show you briefly the designing slabs. So let me open one of the example model. Perform an analysis. During the analysis, let me show you the rehabilitation in set module. So we provide the RC beam straightening and RC slab straightening. For the RC beam straightening, steel plate strength and FRP strength is provided. So enter the beam member force, beam dimension, and the top levers and bottom levers, and number of levers, size, and cover concrete dimension, and FRP sheet straightening data. So checking first check, and then this FRP straightening can be checked. Firstly, we provide the general data and the straightening material, the dimension and reduction factor, and member force and torsion reinforcement, tension reinforcement, and bending moment capability before straightening and after straightening. So checking straightening strain in FRP at required pressure strength. So this can be checked based on our allowance strain we entered here. Then check the shear. Similarly, for slab, we can do the steel plate straightening or FRP straightening. So this, by adding those steel plates, we can check before straightening and after straightening. So let's go back to the midas gen. So firstly, let me show you briefly the stress distribution of this building. Let's see the plate stress with the certain load combination. So I will check the form my set stress. So this shows the how stress distribution displayed in midas gen. As I mentioned, midas gen's graphical results is very good for generating your presentation or report. After that, we can design the slab element. Let me activate one floor to performing the design. I will activate only one typical slab floors, and as I mentioned, we can design the slabs based on the Eurocode 2. And go to my sheet, slab wall design. Flexure design. We can check the reinforcement or required lever area or ratio of the required lever or ratio of the resistance between the member force and resistance, and Udava moment as well. Let's see the required lever ratio. So the results can be checked here. Also, we can see the reinforcement, how it is shown. So which element required which type of the lever.